Welcome. This is the first of 5 videos discussing the end-to-end process of building trading signals, which is the main output for this evaluation of the CWIQ platform. You will have access to the sample Jupyter notebook used in this series. The objective of this evaluation is to build a model that predicts stock returns to demonstrate the code-willing data to trade capabilities to accelerate your time to alpha. Independent variables, XVARs, will be derived from the provided datasets. Dependent variable, YVAR, also called the model's target variable, is the residual returns. This can be found in the residual returns file. Details will be explained later. The model's predictions will be used to form a long-short portfolio, which will be assessed based on 5 metrics: Sharpe ratio, returns, maximum drawdown, up/down ratio, dollars traded. Let's begin with how these predictions are used to construct daily portfolios. Given your model's predictions for all stock I on day T, which in this example is January 3, 2017. First, subtract the medium prediction for January 3, 2017 from the Y-preds. Let's call this X sub IT sub DMD. Now for all positive X sub IT sub DMD, or those stocks whose predicted return is above the median prediction. The weight assigned to each prediction is just the D median prediction divided by 2 times the sum of all the positive X sub IT sub DMD. For all negative X sub IT sub DMD, or those stocks whose predicted return is below the median prediction, the weight assigned to each prediction is just the negative of the DEM median prediction divided by 2 times the sum of all the negative X sub IT sub DMD. These weights correspond to allocation in a portfolio, so how do we get these Y-preds or signals? To get the predictions, we need to first transform the datasets and then construct a model of future returns. In transforming the datasets, the goal is to construct features which can be used in modeling future returns. To construct the features, we first need to perform data preprocessing on the raw data. This involves cleaning, structuring, and merging different datasets. Feature engineering is then applied to derive predictive features of stock returns. The constructed features must be stored in the columns with unique date, and stock in each row. The target variable or future stock returns must also be stored in a column of the same data frame. Once the transform data containing the features and target variable is ready, we can construct the model. We need to split the data into training and predict datasets. We will use the training data with the X and Y variables to fit our model. Then we will use the X variables of the predict or test data as inputs to the fitted model to get the predictions of stock returns. In building the model, timing is very important. We have to make sure there is no look-ahead bias. One thing to be mindful of is to not overlap the training and predict periods. Shown here is a sample timeline of predicting the future returns in January 2022 from a 1-year training sample. In this example, we aim to start predicting at January 1, 2022 and end at January 31, 2022. With a 1-year training size, we train a model using data from January 1, 2021 to December 31, 2021. Since we are to predict future stock returns, we also need to be mindful of having to leave out some trading days at the end of the training period. The number of days to skip is the count of days needed to calculate the future returns we are to predict. In our example earlier, if we want to predict the next cumulative 5-day returns, we need to skip the last 5 trading days, December 23rd to 30th, and thus training only our model from January 1st, 2021 to December 22nd, 2021. A more detailed explanation on this will be provided in the next video. Finally, we have to also deal with model drift. To avoid this, it is a good practice to periodically refit the model. That is, we retrain the model on new data using the same parameters in preprocessing steps. The timeline below illustrates how we refit the model we had earlier from predicting returns in January 2022 to predicting returns in February 2022 and March 2022 and returns in April 2022. We essentially just shift the training period in accordance with the period we are to predict. Therefore, in this example, to predict returns from January 2022 to April 2022, we have to train 4 models. And that concludes our overview of the modeling process. In the next set of videos, we will dive deeper into the specifics of model building, where we'll explore various techniques and best practices that will help you create your model.